Okay, this is an exercise from section 7.2, estimating a population mean. This is question 17, or you can also refer to it as 7.2.25-T. So the pulse rates of 158 randomly selected adult males vary from a low of 45 beats per minute to a high of 105 beats per minute. Find the minimum sample size required to estimate the mean pulse rate of adult males. Assume that we want 95% confidence that the sample mean is within 4 beats per minute of the population mean. Complete parts A through C below. So this is a pretty straightforward problem. I need to calculate the sample size that is large enough that I can feel 95% confident of being 4 beats per minute within the mean. That's just a t-stat. Typically, it would be a t-stat, but they throw us a little bit of a curveball here. In part A, they say find the sample size using the range rule of thumb to estimate sigma. So sigma is, as you know, the population standard deviation. So since we are going to approximate sigma, then that means we will essentially know, at least be able to estimate what the population standard deviation is. So we don't use a t-stat for that, we use a z-stat for that. Remember that when we know the population standard deviation, we switch everything to a t-stat. If we don't know what the population standard deviation is, which is really most of the time, then we use a t-stat. But when we do, or when we approximate sigma, when we know sigma or approximate sigma, we are going to use a z-stat there. Now we should probably review the range rule of thumb. You may recall, so we kind of use range rule of thumb in two different arenas. So we have the range rule of thumb when we are talking about critical values. Right, if we want to do like mu plus 2 standard deviations to find significantly high, so these would be all our high values, and then we use mu minus 2 times the standard deviation if we want to find all our significantly low values. Well, that's not the rule of thumb we're using here. The rule of thumb that we're going to use here is when we approximate sigma, it's the range divided by 4. So that is the range rule of thumb we're going to be using in this example. And fortunately for us, they provided us with a range, right? So they said the minimum value, well, they didn't provide us with the range, but they gave us enough information to find the range. So we have a minimum of 45 and a maximum of 105. So our min is 45 and our max is 105. So remember, to calculate a range is simply equal to the max minus the min. So I'm going to go ahead and take 105. I'm going to subtract away 45, and I should end up with 60 there. So my range is equal to 60. So I'm going to plug that into my approximation of sigma. So this is going to be approximately equal to 60 divided by 4, which, if I'm not mistaken, that's equivalent to 15. So I'm going to say for this example that sigma is approximately 15 beats per minute. And that, again, that is our we're assuming that to be, or we're estimating that as our population standard deviation. And that's why we're going to switch this example. We're not going to use t-stats in StatCrunch. We're going to use z-stats. So that's exactly what I'm going to do. I'm going to open up StatCrunch. I'm going to go into z-stats. I'm going to go one sample with summary. My sample, I'm sorry, that's not at all what I'm going to do. I'm going to go stat z-stats one sample with / sample size. So I'm going to click on that. Now I am going to use a 95% confidence level. That's what the exercise dictates. I am going to adjust my standard deviation to the 15 beats per minute that I just approximated back on this page here. And then my width, they want me to be within 4 beats per minute of the population mean. Well, I could be 4 beats per minute above, or I could be 4 beats per minute below. So if we talk about the width of that interval, that error interval, if you will, the width is going to be a total of 8 beats per minute. So I'm going to double the 4, and I'm going to turn it into 8 beats per minute for the width of the interval. And now when I hit compute, I get a sample size of 55. So n is equal to 55 here. I check that answer, and we get that one right. So that's how you can tackle part A. Now, part B says assume that sigma is 11.6 beats per minute based on the value of S, which is the standard deviation of the sample of the 158 male pulse rates. So the only adjustment I'm going to make here is I'm not going to use my estimated range rule of thumb sigma of 15. I'm going to adjust it to 11.6, which is the sample standard deviation. But again, they're saying assume that to be equal to sigma, which is your population standard deviation. So again, I'm going to do this as a z-stat. And I am going to change my width back to 8 just to make sure it rounds correctly. If you notice when you hit compute, it changes this to a number that's close to 8 because it's sort of fudging the numbers a little bit so that we get a sample size that is an integer rather than a decimal. So if I use the standard deviation of 11.6, I get a sample size of 33, which is a little bit more, it's quite a bit more manageable than the sample size of 15, not that either one are too unmanageable. So I check my answer there and I get that one right. Now, the last part, part C, just asks us to compare the results from A and B. Which result is likely to be better? Well, the result from B is likely to be better because we're using a sample there. Anytime we use the range rule of thumb to estimate a standard deviation, it's okay. It's not hyper accurate. It's good enough for some things. But if we can, we always want to use the sample standard deviation to make an approximation of a population parameter, especially since we know, we know that variance and, well, anyway, we're going to use part B because it is the better estimate of the standard deviation. So the result from part A is larger than, that's pretty obvious, larger than the result from part B. The result from part B is likely to be better because it uses a better estimate of sigma. And that's what we want to key in there. And we should get all that right, and we do. So that is how you can tackle exercise 7.2.25-T from section 7.2, estimating a population mean.